Okay, so for exploring these techniques a bit further, I've taken a new data set that we haven't seen before. And a very popular technique for clustering is what's called customer segmentation, to try and understand different types of customer. Okay, and typically that would be for marketing purposes. So some customers you may want to market high value products to, some customers you may want to, I don't know, market popular products to. It just depends on what they respond to best. And companies do this all the time. So we're going to carry out this exploration on a data set of 300 imaginary customer profiles from this company. It's loosely based on a data set that I found on Kaggle. I don't know if you're familiar with Kaggle. I think I may have mentioned it. It's an organization that runs data science, machine learning competitions with real cash prizes. So if you want the original data set, it's on this link. But I've kind of taken the ideas behind it and randomized them and created a different set of data, but it's kind of loosely got the same attributes. So each customer profile then contains information such as the gender, their age, their annual income in thousands, and the monthly spending at Crisco in pounds. So what's that? 1, 2, 3, 4. Yeah, four different variables. Okay, and first of all, before we do any clustering, I think we ought to get a sense of what this data looks like. So one thing we can do is a box plot. In fact, although we've got gender information, I'm not going to use that. So I'm not using the gender information. I'm just using the age, the annual income, and the monthly spending. So there's the data set. Obviously, you can read it in from the GitHub, and you can print out some details about it. And I'm going to focus on the age, the income, and the spending. See if they've got some interesting clustering there. And then we can do a box plot, as we saw in, I think, lecture 5, where we just select those values and do a box plot, and that will create something like this. Now let me display that. So there's our 3 variables: age, income, spending, and you can see that these values are kind of not particularly. They look pretty normal, actually. They're not widely spread out. There's not many outliers. So there's a few outliers in the income, but the age seems to be from between 18 up to, looks like 79. The income seems to go from around about 10 on this scale up to about 80, 90 maybe. And this is in thousands of pounds. So it's going from 10,000 up to 90,000 with an average of about 40,000. So this is quite a wealthy set of customers. And the spending goes from 0 up to 100 or nearly 100 pounds a month. Okay, so although the data's been configured so they all fit nicely on the same chart, that you can get the idea that these are giving us a sense of what the data is. And there's no obvious, we can't conclude anything obvious from this lot about segmentation or clustering, because they look nicely spread. There's no kind of obvious variables that are very widely spread out or anything like that. Okay, so that's what it looks like. In fact, you didn't even need that plot. You could just use .describe and that would give you these values. So the age is 18 to 78, average of 42. Income goes from 8,000 to 90,000 with an average of 38,000, and the monthly spend goes from 0 to 96 with an average of 45. We can also do histograms to get a better sense of those particular variables. So this is for the age, and that's what it looks like. And if I do a histogram here, you can see the largest age group is the 25 to 34 age group. So this column here with 70 people in it, 70 out of 300. And then, so I would say the bulk of the people in this group are sort of 30 up to 50, and then there's some 60, 70, 80, and some under 25. The code for doing the spending and income distributions is almost similar. I've just adjusted the values here. There's the spending. So again, the spending distribution, most common bracket is this one, 40 to 49 pounds. So people spending about 50 pounds a month. in this company, and the income, as we saw, the highest bracket actually is 40 to 49,000, with also 30 to 39,000 quite high as well. So quite a wealthy group of people. Okay, so we got a sense of the population, but how do we group them? This doesn't really tell us how to do that, and that's why we need clustering. What we could do is kind of manually spot clusters, and because there's only 3 variables, we can try and create a scatter plot, a 3D scatter plot, and try and manually spot the clusters. And this is the code for doing that. So this looks like, it's very like the code we use for doing scatter plots, except that everything's done as a single subplot for a figure, and then that subplot is given a 3D projection. And it looks something like that. I have to say, it's better to run this in PyCharm or just run from idle from the default Python editor than it is inside the excuse me, inside the notebooks, because with a window like this, I can actually move the plot around with my mouse. Okay, so I can attempt to spot clusters, and if I look at the data, if I line it up like that, you can see a sort of cluster up here, top right, another one top left, bottom right, bottom left, and they sort of disappear. But if I get the data at the right angle, I can spot potentially clusters. So 3D box plot is 3D scatter plot is quite a useful thing to do, but it's quite hard to interpret. Okay, and as I say, this works better as a standalone rather than in a notebook, because it's interactive as a standalone, and I can rotate it around. So get pictures like that. So let's do some clustering in the next video. I'm going to finish that video there, and then we'll actually cluster the data.